All right. Well, thanks everyone for coming. So today we'll talk about LangDB, how you can actually build end-to-end LLM applications. We'll also talk about agentic workflows and a few other techniques just using SQL and LangDB. So before I get started, I'm one of the co-founders of LangDB, myself Vivek. I come from a startup background. Have been part of several startups, have been in roles of CTO, and also built up a lot of platforms. Some of them work, some of them didn't, usual startup story. And I have my co-founder here as well, Mathieu. He comes from a data background, has been head of data at several banks and bigger companies which dealt with data. Sequoia, Gradient, and January Capital investors. I'll quickly jump into what LangDB is about. So today, there are many frameworks focused on building LLM applications. If you are familiar with them, so frameworks like Llama Index, LangChain, etc., they're Python based. They work quite well, but we fundamentally believe that building LLM applications, you'll have to work very close with data, right? Data will, it is all about the right data you feed into the context of an LLM, because LLMs are very good with public knowledge. But when you want to build something for your for your company, for your enterprise, you'll have to feed the right context while the LLM is answering those questions. And using that, you can actually build several applications. Of course, chatbots, which we've all seen, agentic workflows, search workflows. You could also use them to extract structured data from several unstructured documents like PDFs, images. It is unlocking many new use cases, right? So what does LangDB solve? So we really target working with data. When it comes to data, we talk about both unstructured and structured, right? So you could basically talk about PDFs, images, and several other formats, and combining that with structured data coming from traditional data sources, MySQL, Postgres, MongoDB, etc., and using that to actually kind of build the right context. So that is called RAG, retrieval augment generation, which means you basically kind of, in the workflow, in the LLM call, you would bring the right data into context, and you would actually kind of complete the workflow, right? LangDB also integrates with several providers, OpenAI, Bedrock, Anthropic, etc. So from an interface standpoint, you would write a simple SQL statement, you would change the provider, and the exact same syntax would work with all the providers, right? And we'll also talk about how to create agentic workflows with tools, right? So today we'll focus on a use case, basically building a HR assistant using LLMs, right? And let's actually talk about this workflow a little bit, and then we talk about how LangDB approaches this. So you would expect a user, in this case a HR person, asking questions. See, this is an example, but you could actually kind of even build a hybrid experience of search with a bit of a full text, with a bit of a natural language capability. It could actually be any of those things. And you would expect these kind of things to translate to real data coming back and helping with the workflows. So, I mean, you could also think about use cases where you can build a automated email, automated support. Those are the kind of scenarios that you can think of, but feeding the right data about the company, all that will become quite important. So let's talk about this example, what we'll cover. So, we'll build a HR bot, which will, in this case, we are using one of the OpenAI models, GPT-4 Mini, and we could have used any other model here as well, right? And HR bot has access to several tools in this application. Basically, perform a semantic search based on text, right? So you would want to match the right candidates when a certain question is asked. So being able to search based on skills, knowledge, experience, etc., and bring that data into the context, right? So that's one of the tools. We also have a tool. We'll also have a tool to get job details. So based on a job identification or a title, to be able to kind of bring that information into the context. And LangDB also have some tools that you could use simply to actually generate queries, to execute queries against the data that you have, right? We'll also talk about rank candidates. This is one more advanced layer on top of what you could do with a semantic search. The light has gone off there, so it's all right. Yeah. So rank candidates potentially could actually even optimize your results. So once the data comes back, you could actually even feed that to another LLM model to further optimize your results, right? And all of those tools will need access to structured data. And we'll also talk about how to create that structured data when you have PDFs and other formats. And in this case, we are talking about job information, resume information. We are basically matching job information with resume information. We're also creating embeddings to be able to do vector search on those data sets, right? To actually create that data set, let's actually talk about the workflow. This is the initial data preparation and extraction phase, where we'll take a few resumes, few job descriptions, extract text out of that, and using the text, automatically extracting structured information. So let's say if you have a PDF of a person, being able to kind of pull specific details about when he has started on a particular job, how many years of experience a person has, right? What kind of skill set that does that person have? These sorts of things, right? So so basically you can see some of those details there, where potentially where he studied, where he or she studied, etc. So we'll bring that information for both resumes and jobs. We'll store that in the tables, and would also create embeddings on those tables to basically perform the vector search that we talked about, right? So that's the second phase, or that's the first phase. Basically, the data that we create here could be used for basically answering questions on the fly, right? So for people that are not familiar with agentic frameworks, basically you have essentially models, agents, models, interchangeable terms. Essentially, you have agents, and agents have several tools that it can work with, and we have seen that before. And LangDB provides these high-level entities to work with to create these things in a very easy fashion. So let's talk about that quickly, right? So you have providers. Basically, provider is in this case an OpenAI provider or a Bedrock provider. And creating that provider would be a very simple create provider syntax, just like you would basically create a table or alter a table. You would basically get a very SQL native syntax. And let's talk about models. In this case, we are if you take this example, we are creating a model called review, and we want to get a sentiment score back, right? So let's take that very simple example. And for that, we would want to also create a prompt, which basically determines how to you're instructing LLMs to basically calculate a sentiment score, or basically give a sentiment score based on the text provided, right? So that's basically one model. And just like in a database, we also have views. You could create any complex SQL and expose that as a view. So if you see here, when we created that model is easily accessible through select interface. You could simply call select review, right? Just like any function in SQL. So you could actually create dynamic functions that can call models, and you could do that on the fly. And you could also attach models as tools for other models. So in a way, you could basically recursively add many models that can do several things, and you can construct a very complicated workflow through this mechanism. And you could also do the same for views, right? So example for creating a model with tools will look like this. So we are creating a model called product manager. We're taking some input. Here we are using OpenAI provider again with a specific prompt, and we'll talk, we can go to the syntax of prompt in the example later. And we're associating that model with several tools that the model can use. So in this case, the previous review that we have created, which is a model that gives a sentiment score. You have a view to calculate average sentiment, which is basically a select group by. Let's actually quickly look at that. So if you see, the view is not just a LLM call, but it is also aggregating sentiments across several reviews, and you have access to that as well as a tool. And you basically also can create a similar tool to compare products as well, right? So this can give capability to a model called product manager to be able to use any of these tools dynamically while you actually call it, right? So once you create those views and models, you could actually call them using SQL, and they're also available as APIs. So you could specifically call a view to execute, or you could invoke a model. You could also stream the results. To work with unstructured data, LangDB provides many of these functions by default. So you could actually use functions like list files, it could be any of the directories, it could be S3, it could be GCP, it could be FTP. You could point at any of these locations, you would get a list of locations. So that's just one example. Similarly, you could use load to load binary data into context, and you can use further functions to get the data that you want to process. So extract text, extract layout, chunking, HTML, scrape. We provide several other functions. You could use that to construct the structured data that you would want, and kind of use that to combine with unstructured data and use it in your RAG, right? And if some of these functions are not sufficient and you would want to integrate with some of your functions that you want to create, you could also do that. You could implement a remote API and implement these 3 functions to discover an API that basically gives function definition back and a function to execute that particular Lambda function. You could simply register that in LangDB, and that function will be callable just like you would call any other function in LangDB, right? So there are some samples on our application. Feel free to check them out. I mean, this is I'll get to this later. Now, actually, let's jump into the example that we talked about, right? So let's kind of quickly recap. So the first flow, we are building an assistant flow which takes raw questions, uses, right? Okay, let me try that. Is that better? Okay, I think that's the best I can do. Yeah. Right. So maybe I go full screen. That'll be better. Yeah, let's try that.
I don't know how this works.
Yeah. Maybe.
Normally they should both be on. Okay, never mind. Let's just go on.
Right. Yeah. So let's quickly review the flow that we discussed. In the HR bot will take questions in natural language, uses bunch of tools, queries the data, and answers back, right? And to empower HR bot to do that particular workflow, we'll go through a few ways to actually extract unstructured data, structured data from unstructured formats, and we'll store them in some files, right? So let's actually minimize that. In this example, we are going through a few tables. We have resume data, resume embeddings, we have job data. Just like we talked about before, we have prompts for extracting resume, extracting job, we have a prompt to re-rank, and we have a prompt for the final HR model as well, right? And let's actually look at some examples here. Essentially, you would create a prompt, something like this, right? So you would basically instruct an LLM to do particular things, and you would instruct the LLM to also give you a certain format. So in this case, when we point the model at a particular document, we are asking the LLM to extract personal information, full name, contact information, location, professional summary, work experience, education, skills, and there are a few more instructions to actually kind of fine tune that. There is still a chance for some errors to happen. So in a real production scenario, what you would do is basically connect further validations as tools, and you would use those validations to make the results even better. Right, this is one prompt, and as you can see, it's quite elaborate in a way. We are talking about extracting this particular document, and similarly, we are using another prompt to extract job details, right? And we are expecting the results to be in a certain JSON format. We're also instructing how to actually rank candidates once the results are back, and we are finally putting together a prompt that will create a HR bot, which will use all the tools that we have just spoken about, right? So this is initial setup. So I will just close that, and let's also quickly look at the tables involved. So this is a table, resume data. We are creating a table. So LangDB is built on ClickHouse. If you are familiar with ClickHouse, it's a very fast analytical database. It can do some of the analytical queries very efficiently. And we are also using a very nice capability of ClickHouse here to be able to materialize data on the fly. So when we write JSON string into the column JSON, all the rest of the fields are automatically populated through the materialized behavior. So what we are essentially doing is basically extracting some data from a PDF. We are using a model to convert that to JSON, and that JSON is inserted into the JSON string column. Automatically, the rest of the columns are populated, right? So that's the workflow. Okay, so I will close that, and let's actually kind of run some queries to explore. Because it's a Python meetup, and we also have a Python client, so you could actually use LangDB. I'll just quickly. So basically, whatever you see here is runnable. It's a Jupyter Notebook. Jupyter Notebook JavaScript version. It completely runs in the browser. So basically, initialize LangDB. You could basically run any queries on the fly, and all the queries that we saw earlier are also possible here. So for example, let's actually take this one of the documents. So this is a PDF document, right? And this is a generated PDF document. It's an anonymized document. Here we have some details. This is an accountant position. We have some information about the skills, educational summary, and all the previous jobs that the person has held, right? And similarly, let's also look at a job position. This is talking about the requirements for the job, the skills that are necessary for performing this job, right? So let's actually run an example. In this case, we are running extract text, and we are passing this query. So if you see what's happening here, essentially we are using a function called extract text, and further sending that the output of extract text, we are forwarding that into extract resume. This is the LLM call, and because we have created that LLM through create model interface, you could simply run that as a SQL function, right? So basically, when we run that, especially when it involves large contexts and extracting data from PDFs and etc., you can expect it will take a few seconds, right? And you can see that the information has been pulled out of the document. So full name is not provided because it's an anonymized data set, but you could actually see some of the other things that have been processed. So work experience, we have company details, job title, start date, end date, all that. So essentially, we can point LangDB at a file, use extract text, which will get you just raw text, and we are passing that into an LLM model called extract resume, and we have a structured JSON document to work with, right? Let's switch back to the previous example, right? And I will quickly show to create views. So basically, this is the same interface. We are using Python on one end, but it is actually running SQL just like we saw here. So when we just run extract text, you would basically get text in a string format. And as you can see, this is a database type interface. So essentially, you will get back a table every time when you query, and you could use Python. You could use a data frame as well to actually modify that data frame syntax to modify that. So just the text that we have seen here, let's actually kind of let's also look at a sample job description that we have seen. Similarly, we can load the text from a PDF document. So extract text is doing that. There are also other functions that we support. Just as an example, in some cases, you might want to chunk the text into smaller pieces. So you could actually kind of do recursive searches while you feed data to LLMs. So that's what we are doing here. There are several parameters that we support. You could use chunk size, you could see overlap, you might want to trim, you might want to do semantic chunking, which means you don't want to cut in the middle of a sentence. So basically, then in that case, like we would basically make sure that sentences are not cut off, and even the chunk size is a like it's not strictly the limit that we have given. The model will figure out a way to chunk it appropriately, right? So that's just an example. So this is the magic query, right? So basically we are extracting text from a file, extracting resume, and we are using some JSON extraction syntax to get the information that we would want. Essentially we get back a data frame. So we are taking the PDF and with a few commands go from unstructured, completely unstructured format to properly structured format, and because it's a database, you could simply write that back into a table, insert into another table, and you can write that, and immediately you can plug that into your business analytics dashboards. You could use that for queries. You could also use that to support RAG use cases downstream, right? So that's just a way we could kind of work with several PDF documents. That's just an exploration that we have done. Let's actually talk about how to store. Basically, as you can see, we have seen processing one PDF document. Now we are actually processing several PDF documents all in a single call. Again, because it is SQL and processing data is very, I think that's one of the reasons we think LangDB is quite suitable for this purpose, because we are actually working with data frames. Like we have bunch of links. We bring that data in line using several functions that we have. Use a LLM model, and then get that data, write that to table. You can complete all of that in a single SQL statement, right? And if you look at, let's look at a resume data table again. So because we are using the materialize functionality, when we write to the JSON string, other columns are automatically populated. This is a ClickHouse feature. So what we have done here, by just running this command, essentially all the data is processed and you have that available in your resume data table, right? I mean, just let's quickly look at, because it will take a minute or two to run that. So I've already done that before the session. So I'm just going to query the resume data table, right? So basically, this is the resume data JSON column. And so we have all the data that we want in here actually. So okay, so now let's actually go into let's talk about how to actually create a model using that actually kind of calls this. So we have done the first part where we are able to extract data from unstructured documents. We have gone through how to actually put that into a table. Now let's talk about the second workflow, which is the assistant workflow, where we will use the extracted tables and use a combination of tools to answer the queries on the fly, right? So let's actually kind of quickly cover that as well. So before that, let's actually open the create final model. This is the syntax that we have seen earlier. Create model, you take a question and you provide multiple tools. Get job, search candidates, LangDB, rock query. All of these are available for HR bot to execute, just to see how that will look like. So I have put some Python examples here. So for example, if we leverage search candidates, execute view Python command, and we pass in parameters called skills, parameters with skills leadership and some work experience, right? We basically are doing a semantic search on the data that was processed, and you basically get some candidates. And in theory, we would basically send this data again into the downstream rank candidates to basically figure out if they are the right candidates or not, and based on that, we'll reprocess information, right? So that's the execute view command. Again, it works very similar to if you just run that in SQL with search candidates. Let's actually do that as well, just to see how that will work. So we can run the exact same thing using select. Selects are from search candidates. Let's use the exact same parameters, leadership, and work experience. We have financial analysis, skills, financial analysis. So essentially, we have the same interface. It will return a table, and in Python, it's automatically converted as a pandas data frame. But here we are basically working with a raw table from ClickHouse. So create search candidates. Let's actually quickly recap on the definition again. So just so we can see how that was created. Create models, prompts, and views should be here. So just like any SQL query, as you can see, there's a lot of things that are happening here. We are getting the structured information from resume embeddings, and we are joining that for the resume data. And we are also doing a cosine distance function. This is the semantic, well, we are doing a semantic search here. We are using cosine distance to find the distance between two different basically documents. So in essence, we can use the same functionality to use content from a resume, compare that with content from the job description, and using that we can create a score. So this is search candidates. And just like that, let's also quickly talk about the other thing. This is a create view get job. So let's actually try to call that. So let's say if you call get job, let's actually give a job ID that we have here. Select get job. So it can only be used as a table function. So so basically this is one of the job descriptions. And if you look at the tables that we have here, so let's start from job data. Right. So basically that's the information back from a job data. So let's actually not query the JSON column because it's actually taking up all the space. I will just run this query in Python as well, so you can actually see how that looks like. LangDB query df. You could use select star from job data. Yeah. So so we have that information now, and let's actually try to now look at how the final model looks like. The final model is using some of the functions that we have just created: get job, search candidates, LangDB raw query, right? And to actually kind of visualize how that looks like, let's actually kind of run the command. So you can actually see the full dependencies of HR bot. So in a way, if you had some models as tools, they would also have dependencies, and that will be a full tree structure, right? So HR bot is depending on search candidates, which is a view, raw query, which is a static tool, get job is a view, but we could have also given other tools, other models as tools, and it will become a nested graph. We could also kind of quickly look at the tools, the descriptions, etc., because this will be important for the context of the LLM. Okay, let me just collapse that. Okay, so basically, so I didn't go through all the steps. Some of the steps will take slightly longer. We'll share the link after the session. Feel free to explore further. So there is a way to actually extract data and write that back to resume and job data. And the output of that would be, so finally we have a HR bot that you could simply ask a question. So basically, who are the two most recent applicants? The response we asked in the prompt to be in the JSON format. And here we are basically have the most recent applicants. Let's ask some more questions. So we're asking for how many applicants with more than 10 years of experience. We'll get that back. So essentially what we are doing here, and let's actually understand that a little bit. So when we actually ran those query, so let's quickly look at the traces. So when we actually ran that query, we are feeding OpenAI with basically saying, see, this is the prompt information. So we are actually instructing LLM how to behave and how to respond to a user query. And the second message will be the question, how many applicants with more than 10 years of experience? LLM comes back with a response. So that will be the tool calls. So it basically said, okay, wait, I have access to some tools. Go and call that specific tool. And for that, we will look at all the tools that we would have, execute that tool. Essentially, this is the query that we have gotten. So select count star from resume data where earliest start date, and we basically have the SQL query. So the query that we have given, so how many applicants with more than 10 years of experience, basically translated into a SQL query based on the tables that we have provided to the LLM and based on the context that we have provided. And it basically came back to the query that was executed, and we sent that information back to OpenAI. OpenAI came back with a response, and that's the final answer, right? So you could actually use that. So essentially, let's actually open the Python notebook for a second. So in a client application, what you would do, essentially you would build all of that in a SQL workflow. chain multiple models together, chain multiple views, multiple models together, and simply call, let's actually something like this, right? So langdb.invoke model, and we basically will get a JSON response back, right? So the difference, you could actually, so this is how like how it would work if you would directly interact with OpenAI as well. But here we are programming actually using several agents together in an agentic workflow in a chain fashion. So that's the main difference. So we could also, there's also one command that we support. Let's quickly look at that. So basically we could also run a command called chat, and we could say HRBot, and basically we would get something like this. So this is more for a developer experience. While you're building a model, while you're exploring several things, you could actually kind of have a chat widget right within the notebook, and you could ask the same questions. How many applicants? A total of 10 applicants. So, and if you see the exact query that has happened, when we ran that query, will be very similar. Basically, that was automatically translated to a SQL query, and that went back into a data, right? So let's recap, right? So what we have done here is we have created a bunch of tables. And we have populated that with data coming out of PDFs, extracting unstructured data, and populating that in a structured format. Now you could simply access this data in using APIs, using SQL queries, or using a chatbot. And to do that, we had to create prompts, models, tools, and we had to connect a bunch of them together. And for this, all you had to do is basically go from in a single notebook, we are writing SQL statements to compile all of this, to put all of this together. And you could simply integrate that within products. So that's what LangDB offers. I also wanted to show this quickly. So exactly the same thing what we have here. So you could also use Slack as a client to kind of query LangDB. So here this is connected to the same API, and basically you could actually turn a Slack channel LangDB to answer any of the Slack channels. Also, I've created one more channel here. We are connected another model called review. So for example, we could ask your product is terrible, LangDB. I should not say that, but so essentially it came back with a sentiment score that it was calculated, and we can actually see the traces right here within the application. Sorry, 1 second. So review. Let's actually look at what happened here. And there was a model call. The input was passed with the prompt, the user response, the product is terrible with the value, and the output was calculated and was sent back. So we would also have user information, etc. If you are interested in learning more, feel free to talk to us afterwards. We'll explain a bit more, where we can actually use usage information to actually craft even LLM applications in a much more advanced fashion. This is obviously an example. In a real scenario, you would actually create models with multiple nested workflows to make sure the accuracy of the answers is up to the mark, and we would also have several validation loops in place to make sure things will work nicely, right? So yeah, so I'll just quickly go back to the screen. So just like we used a bunch of functions that are provided by LangDB, but in a real world scenario, you would have to kind of integrate with your own functions that you would want to create. For example, we might not be providing sending an email as a function right now, so you could actually implement your own function or your own API that you have. You could simply turn that into a function that is callable within LangDB by just implementing a definition, how to execute, and what's the schema that is returned by the function, and it's immediately accessible within LangDB. So here we have a Rust example. LangDB is built in Rust, but we would be soon making this available in Python as well. The interface will remain the same. It's basically APIs and it's JSON data being exchanged, right? Right. Sorry. Let's quickly, just a quick recap, and again, and then I will stop my presentation. Happy to answer any questions. You have a bunch of samples how to work with several other things, like how to actually use PDFs, how to, there are some advanced techniques as well, how to do SelfRAG, how to create a text to SQL, self-serve analytics. So you can find some of those examples on app.langdb, and I'm looking for a QR code. Okay, here, there's a QR code. So that's the link for LangDB. Feel free to try it out. And we have a developer-only tier. So, and it's very generous. We are in beta. We're currently working on multiple pilots. So please sign up. And if there's any feedback, let us know. We're continuously evaluating what we offer in LangDB. And some of this will be also made open source. So that is something we can work with the developers.